Today I'm going to talk to you about my favorite Osquery table, mdfind, and how you can use it to prevent potential data breaches within your organization. So by a show of hands, quickly, how many of you have written an Osquery SQL query? Probably everybody. This is just an exercise opportunity. And then how many of you have written an mdfind query, out of curiosity? All right, so a decent number. That's awesome. This is some contact information. So I think we can all agree data breaches are a problem. And while P.T. Barnum once said there's no such thing as bad publicity, our respective marketing teams would probably prefer we weren't in these sorts of headlines. So data breaches are on the rise. Every year we're moving further and further towards a totally paperless e-commerce marketplace, and more records are being stored electronically and off-site. In 2018, there were over 1,200 data breaches affecting more than 446 million individuals. With a general upwards trend, it stands to reason that data breaches aren't going away anytime soon. So how do data breaches occur? Well, there are a large number of avenues for data exfiltration and proper disclosure. In Verizon's 2019 DBI report, they cited data mishandling as the second most common cause of misuse type breaches. And the improper storage of data can expose you and your customers to risk. But how do databases end up getting mishandled, and what can we do to prevent it? So this might be a scenario that you're familiar with. A customer reports a bug in production. Your engineers go to investigate it. They find the bug can't be reproduced in local development, and so they think to themselves, what can I do? I know, I'll download a copy. So they make a backup of the database. They replay it into their local instance of Postgres. They fix their bug, and then they delete the backup, right? Wrong. So now thousands of customer records live in an unencrypted backup, lonely and forgotten, miles deep in the downloads folder. And while making local duplicates of data isn't necessarily evil, it still can put your company at risk. So how do we find these backups? What are some common characteristics of these files? We've got things like the file type maybe is a .db or a .sql. Perhaps it has a large file size, or it's downloaded from a consistent source, or it has a name like backup, maybe, we hope. Usually it contains customer data. That's usually a good way to know that it's a database. So let's look at what we can do with Osquery. We could use the file table, right? So we'll use the file table. So we'll do a nice little search. We'll say select star from file where path equals slash wildcard, and the size is greater than 100 megabytes, and the file name something like backup. No problem, right? File table supports recursive searching. Nope. Unfortunately, thanks to symbolic link loops, you're going to run into issues with recursive searching. Also, the file table doesn't really have any introspection capabilities. You can't look inside the file's contents. So we know that the file table isn't going to solve our problem, so what will? There must be another way. And I'm here to tell you there is. It's our nice little visual diagram of how this works. So what is mdfind? Well, mdfind is a macOS system utility which powers the Spotlight OmniSearch feature. It was first introduced in 2005 with OS Tiger. It's a highly performant, fully indexed search that goes across 200 plus metadata attributes. It supports Boolean operators and other basic query functions. And the most exciting capability is that it actually indexes the contents of many common file types. So how can we interact with it? Well, the way that most of us are probably experienced with mdfind or Spotlight is using the GUI inside of macOS. I use this thing probably 1,000 times a day, if I had to guess. It's how I find every file on my computer. Then we have mdfind, which is the CLI component of Spotlight. It has support for basic Spotlight-esque searches and also allows us to build more discrete Boolean queries using specified metadata attributes. Then we have the MDLS CLI utility, which allows us to print out the various metadata attributes that are associated with the file. And then we got some less interesting stuff like mdutil and mdimport, which allow us to control the indexes and what gets imported, what doesn't. And then most excitingly, we have the mdfind Osquery table. So this table was first made possible thanks to my lovely colleague, Victor, who built a launcher table called Kolide Spotlight. And then later it was added to the core project by Mitchell Grenier, who goes by Obelisk. And this thing is awesome. It allows us to pass Osquery mdfind queries and return any of the paths of matching files. So let's explore, for anybody who hasn't done this before, how we can interact with the mdfind table in Osquery. So at first blush, when we look at this schema, there's not a lot going on. We got 2 columns, and they return path and query. But it's that second column query that really allows for some awesome stuff, because we have basically a free-form input to type in anything that we can think of that is cached by this index in Spotlight. So you might notice that this little sample query that I've got here, it's got something kind of funny in it. It's got this KMD item FS name. And this is an example of an mdfind metadata attribute, which we're going to be using to construct all the queries in this talk. So most all metadata will follow this standard naming convention. You'll have this K, which is Hungarian notation for constant, MD for metadata, item, because it's an item, and then the attribute name. So it's not that hard to parse once you get used to it. And there are over 200 of these metadata attributes indexed by default on macOS. And if you want to get an idea of where they are, how many of them there are, you can run this command in your terminal, mdimport-a, and it will spit out this disgusting list. Most of these are useless, and you have no need to ever consider them. For our purposes, we care about 6 of them. That's usually going to cover most of the things that you can find or that you'd want to find. So one of the other difficulties to getting started with mdfind is that instead of SQL, it actually uses its own query syntax. I've included this slide not to read it verbatim, but just to give you the resource when you're going back to your own queries and trying to get these things written for yourselves. But as you can see, it supports basic Boolean operators. We've got ands, we've got ors, we can nest things, we can do simple sort of comparisons. It's great. So now that we have everything we need, let's see if we can find our orphan database backups. Below is the file in question that we're going to be looking for, and hopefully we can do it. And I am going to try to do a demo and not embarrass myself. We'll see how that goes. So I'll show you the basic query first. We're going to be changing it up a little bit for the sake of the demo. But the basic query here is going to be select path from file. We'll join it on mdfind, where our md query equals, and we'll start with a very basic sort of file name as our indicator. So I'm going to, if you could switch me on mics, because it'd be hard to type and do that. Awesome. All right, what do we got? All right, so I've wrapped everything into a nice case statement for myself, just that we can see how many things are being printed when I run my query. So we'll start with a very simple, show me any files that contain, or that have a file name with the string backup. And I will try to type most of these things correctly. All right, so we found 180 files, but we only have one database file. So we're getting a lot of noise in the results here. So let's try sort of scoping this down using some of the things that we had discussed earlier as possible avenues to reduce this, this data set. So let's say things that are over 100 megabytes in size. All right, so that would be KMD. We'll use our name still. And we're using wildcards there to catch anything that has backup in it. And then we'll put an AND statement. And we'll do greater than 1, 3, 4, 5, 6. I am missing an equal sign. Thank you. Wait, yes, I am. You just saved me some heartache. I really appreciate that. All right. Okay, and I think that's it. All right. 13 files, great. So we're definitely trending in the right direction. Let's do something way cooler though. Why don't we use what we talked about before, the ability to inspect the contents of the file itself. So if we use a known UID that we have that we know ahead of time is going to be in our database, we can hopefully get just the item in question. All right. So we'll do our all right, and because I am not going to be able to type this without screwing it up, we will just copy paste like cheaters. And should be good. All right, great, we found it. We've got our database. But one thing that you want to consider when you're writing these mdfind queries is that sometimes too much specificity is a bad thing. So what if I told you that there was another file on the computer that also was a database backup, the same database backup? Well, how would we find it? Well, maybe let's try doing something a little simpler. Instead of having all of those other conditions like the name and the size, let's just look for anything that contains that known string. Aha! So we actually have two. So sometimes being less specific can actually be a good thing when it comes to finding these files on your computer. What if, however, you made a backup or downloaded a backup that the file contents couldn't be inspected? What would be another sort of way that we could look for a file perhaps that we downloaded from a known source? Well, I've got a Heroku backup here that I will go ahead and search for using the KMD item wherefroms clause. So in this case, we'll do select star from mdfind. We'll do select path. That'll be cleaner. I'll put myself in a new line. What do we got here? All right. Aha, now we find our nice hidden Heroku backup. Awesome. Well, let's go back to, one second. There we go. Lovely. So, all right, we did it. We're the best. Nice that it went through and worked. Hey, yeah. But sometimes mdfind isn't going to work for you. So I'm going to go over some of the caveats really quickly, just that you know going into this what you can expect and what will and won't work for you. So first off, obviously, mdfind is a macOS CLI utility, so it's only going to be available for querying Mac devices. Unfortunately, it can be disabled by the end user, and grumpy old developers who remember when it first debuted back in 2005 probably griped about how the performance was a burden for their spinning disk drives, and they might still think like that it's superstitiously that it's still crippling their computer, and they might turn it off. It's also limited to user visible directories that the user can sort of optionally extend with additional omissions. It attempts not to cache files that appear to contain key material, so if you're trying to find SSH keys with this, it's not going to work very well, but PuTTY keys, for whatever reason, do work. And like I said, it uses a different query syntax, so you got to get familiar with that. Luckily, we can check for some of these things using Osquery. I've included those queries for you here today, so you can look for the exclusions that your users might have set on their device. You can also find the item kinds that they might have excluded, so they can say, no to applications or no to bookmarks, etc. And then you might want to consider, additionally, the privacy implications of using mdfind. A little while back, somebody had written an Osquery virtual table that they proposed to merge into core called MDLS, which would actually print the metadata attributes for a specified file. You'd supply the path. But there are some things that mdfind caches that or indexes that you probably don't want to display from a privacy standpoint. Like iMessage transcripts and the phone numbers that are involved with those things. Or when you get an SMS that has like your recovery backup codes or your two-factor codes. And there's actually an ongoing, or there's an open issue in the OSQL repository at the moment, opened by, I'm going to say this wrong, Robbie Ostrowski, I think, who discovered that there's actually a data leakage potential for the mdfind table, wherein he wrote a Python script where he was able to abuse the wildcard functionality of mdfind in order to enumerate the contents of the file. So that's not so hot. Not a great look for mdfind. But there are some good news. There is some good news coming down the pipe in terms of privacy implications. macOS 10.15 Catalina is changing some things. And it's going to limit the amount of stuff actually that mdfind can introspect without explicit user permission. So you probably want to keep that in mind as you're writing these queries and depending on them in your environments. So find while the mdfinding is good. I've included a couple other fun sort of examples of things that you can achieve with mdfind, such as, looking for photos that were taken within a sensitive location, like an R&D facility or military base. You can scope to lat and long. You can, as we said, find items downloaded from a specific source. So finding, in this case, Google G Suite 2FA backup codes. We can do things like finding items from a specified time range because mdfind supports a time operator. So let's say that your developers are making exports of the CSV every day and they forget to clean them up. We can find the ones that are older than 14 days or whatever. And then we can use mdfind to determine how much disk utilization we're spending on certain item kinds. And if we want to get really fancy, we can join on extended attributes, and we can actually output some of the metadata that is available. So for instance, our wherefroms that we took a look at earlier, we would be able to, dare I go back into a demo? So if we wanted to be able to see exactly where that Heroku data store had come from, we can run that query and we can see the actual URL printed out for us. So we can see that it came from data Heroku data stores, which was stored in an S3 bucket. All right. So I got some additional reading for you guys if you're interested in continuing to learn about this. And I've got a lot of extra time. I went very fast, evidently. So I'll open up to any questions that you might have. All right, you in front.
Can you go back to that slide?
Additional reading. Yeah, no problem. Any other questions? Yes, you over there.
What are you going to do about Apple 10.15 with those logos?
That's a great question. So the question was, what are we going to do about Apple 10.15 and as Apple sort of tightens down the screws on user privacy and keeps us from introspecting various things? Like we won't even be able to run a select star from file where path like /users/downloads with 10.15. It's a great question. It's something that I think that we as a community are going to have to grapple with and determine the best avenue forward. We've looked at internally how we can expose the capabilities of Kolide to the user so that they feel comfortable granting those additional permissions for Osquery to be able to introspect those areas. But it's going to be definitely a rocky road initially in terms of getting past or grappling with the limitations that 10.15 sort of puts on us. So I hope that sort of addresses your question. Yeah. What's that?
Not pulling back to Apple and ask as a community, ask and give acceptance.
That's right. And so, I mean, 10.15 is in beta right now. It stands to reason that this probably won't change drastically. But there is some hope that maybe there will be an expansion of the granularity of these permissions. Victor, I saw you had your hand raised, and then I'll get to you, Eric.
Yeah, I just wanted to add a comment to that. And it's increasingly clear that if you want to use Osquery or any other tool that does similar things, you need to pair it with an MDM. Apple allows the president to say, I own this device and my employees accept the user policy, therefore I have these additional rights. It doesn't exclusively allow everything, like you can't allow a microphone to always be listening. Like you can't just have everything do that for any means, but you can allow access to like the download folder.
Nice.
So you have to whitelist Osquery as through a configuration profile, push it through an MDM to supervise the device.
Awesome. So just so that the audio, when you guys upload this later, has it. Victor said that utilizing an MDM in order to whitelist Osquery is an avenue forward in terms of granting those permissions to Osquery from the get-go, and that Apple allows that, pushing that through an MDM. Eric, you had your hand raised. Sorry.
That's actually what I was going to say.
Okay, great.
And yeah, if you, the requirements are either DEP enrolled or user enrolled MDM, and you can craft a like a privacy package payload to whitelist Osquery
Awesome.
for macOS going forward.
Wonderful. So DEP being another option. Great. Other questions? Yeah. If not, I will return the time. Awesome. Thank you guys very much.